Okay, for today, this is a review for your test. Chapter 3, it's on composition and inverse. All right, so the first half was on like one function eats another function. In this case, we aren't even having functions eating each other yet. We just have a function being divided by another function. But a lot of kids are not going to notice that they can simplify it. Please divide these two functions and then notice that you can simplify it. If you don't simplify it, you're going to have to lose points. And if that was the only mistake in a multi-part problem, I'd still have to take off 5%. That's a lot off your test grade. So, yes, you may. So here's F divided by, here's G. And how can you actually get those to be all into one fraction? Well, it's a fraction in a fraction, and that's what's not kosher. You can't leave it that way. You have to fix that. So, hint, if I just put this over 1, do you get now it's a true fraction over fraction? And you have a top 20 that deals with that to remind you that you can simplify that. I'm not going to say how. I hope you remember. Try to remember, if you had a simple fraction like 1/2 over 3/4, do you know what you would do then? Okay, I'm going to pause for a second while you think on that one. Then a lot of people need to be reminded. So if I have 1/2 over 3/4, that would mean 1/2 times 4/3. So if I have this fraction over that fraction, and now I want to simplify it all into one fraction, I can change it to 2x squared over 3 times 1 over square root of 2x plus 1. And that will simplify down to just one fraction. 2x squared over 3 root 2x plus 1. As simple as that. Isn't it funny that that's a nice simple answer in this class? And like 2 years ago that I've been like, never seen anything like that before. All right, that's actually the easy part now. All right, now what we just did there was to divide two functions. Do you remember that this is the tricky kind that has 3 number lines involved to find its domain? It's based on F, it's based on G, and it's based on something else. Would you please try to figure out what the domain of F divided by G of X is? It was the tricky one. It's not the one with the formula. That's when a function eats a function. That's a composition of functions. And if these first 2 questions have been rough for you, then you should be afraid. So here's our domain of F. Obviously, then that begs us to find the domain of G. And has anybody got that already? All right, I'm going to pause for a second while you guys work on. If you need F and you need G and you need one more thing, let's see if anybody remembers it. I'm going to pause for a second. So to find this, you have to find 3 domains. Did you figure out it was domain of F, which was given to you right here? It's x is greater than or equal to 1. So here's a 1 greater than or equal to 1. That should have been easy. And then you should have said, oh yeah, of course it depends on the other parent, d of g. Domain of g, which you figured out already, was 2x plus 1 greater than or equal to 0, 2x greater than or equal to negative 1, x greater than or equal to negative 1/2. Raise your hand if you already had that. Awesome. Then that has to be another one. Here's 1/2, and greater than or equal to 1/2. But then there's something else. That's actually greater than or equal to negative 1/2. Sorry. There we go. And there's one more thing. What's the third thing? Only 2 people would have got this one right. Oh, maybe 4. Yes. Yes. Sorry. X, yeah, you were both raising hands. Okay. X cannot equal 0. Explain why. Okay, now you're close in what you're saying, but you're not saying it exactly right. When you say x can't equal 0, I'm taking that very literally and saying I shouldn't let x be 0. What I think you mean is the denominator can't be 0. You're right. G cannot be 0. That means g of x can't be 0, which actually, what would cause it to be 0? Negative 1/2. If you put in a negative 1/2 here, that's when you'd have trouble, because then it would turn into 0. But some of you are like, but you said before it's okay to be 0. It is okay for a function to have the square root of 0, which is just 0, but not when it's on the bottom. See what I'm saying? So the question isn't saying, okay, I can't let x be 0. It's I can't let g of x be 0. So g of x, how can this be 0? If x is negative 1/2, it would be 0. So my third number line is that negative 1/2 can't be allowed to happen, because this is the domain of g cannot be 0. It can be everything else as long as the g function doesn't turn equal to 0. Find it. Looks like it. Either that or you stole somebody else's. All right. I'm glad you found it. That's good. All right. So then where do they all overlap? Actually, all of that malarkey didn't even mean anything this time. It was just bigger than 1. The final answer. All 3 number lines boil down to, notice you had 3 number lines when you divide. All right, now let's move on to a different kind. If I give you 2 functions, you should be able to make the one function eat the other function. Okay? And then use a formula like this. Let's just look over this question for a second. Do you get it already had a domain that was given to them, and then the kids had to figure out what would make the domain for g, and then they had to remember that with this kind of inverse problem, you needed this kind of formula. All right, let's see if you can handle that. Ready? Different one. F of x equals 2x squared, but that would be all reals. So I'm going to say x needs to stay greater, actually let's say x is less than 1. And over here on the g function, we're going to say that our equation is nice and simple. It's just 2x plus 4. But we're going to make this the square root of 2x plus 4. And then, again, that's not too tough to find the domain. Now, I could ask you f plus g, f minus g, f divided by g, which is the kind we just did. And that has how many number lines for its domain? 3. But this time I'm going to ask you f of g. Would you please figure out f of g of x? That's one question. And then separately, what is the domain of f of g of x? That's the one who needs the formula. I'm going to pause for a second while you try that. All right, so let me see here. I'm going to unfreeze my board so I can actually see what's going on. Oh, sorry. That's for next slide. Here we go. This guy's domain of f is x less than 1. Domain of g is x greater than or equal to negative 2. Is that right? Excellent. All right, then how do you put it all together into one thing? RH in the back row. Tell me, how do you put g into the f? Or think of it this way, f eats the g function. Tell me what to write. I want this. Feel like you just woke up from a nap or something. I'm trying to, and you can do this.
I got the answer.
Excellent. Then tell me what it is. Yeah, that'd be great.
Okay, so first, I just put on the equation. So I had
Okay, I'm going to put the F equation. 2 empty spots squared. Okay, now what?
I'd like x is greater than or equal to -2.
I think you're doing the domain. I don't need the domain yet. I just want to have the one function eat the other function. Did you actually do that part, or did you just jump to right to the domain? Aha, okay. This is important to note because on the test, we expect you to first find this new function where the one ate the other. Okay, so I know you didn't do it before, so I'm going to call on somebody else then. Okay, Mr. O. Boo. Okay, AC. Yep, yep. Excellent. And how many of you noticed that you can simplify that? Awesome. Because when you just square the square root comes off. And it's 2 times the 2x plus 4. Here's something I see all the time. People go, oh, so it's 2 times 2x, so it's 4x plus 4. 4x plus 4, right? No, they forgot to distribute. You got to put parentheses around these functions. And remember to distribute that out. So 2 times the, yeah, that canceled, but 2 times the 2x and 2 times the 4, so there we go. 4x plus 8, raise your hand if you had that one right. Okay, awesome. Now, if you just look at that, would you agree that that looks like it would not have any domain issues, like it should be all reals? Because it doesn't have a square root, and it doesn't have a denominator, so it seems like it should be all reals. But we know better, because this had an artificially restricted domain in it. And so I'm going to use this formula. D of f of g of x, that means domain of this thing, is, and now dice of destiny are going to pick one of you to tell me what that big old scary hairy formula is. Row 4, person 1, that's you. False. It's a formula. There we go. Domain of, which one do I start with, G or F? Domain, no! Okay, it's domain of G intersected with, just listen to the whispering. G of X in domain of F. Good. I hope you remember that one because we will not give that to you. You have to know that one. Unlike there's another big formula earlier that I told you don't bother to memorize this one because we're going to give it to you. That was the difference quotient. Do you remember this one? And some of you are like, I wish we had to know that one because I know it. Can anybody do it? Minus, close, all over H. We'll give you that formula. I'll come back to that in a minute. Okay, so back to this. OC, like Orange County. Can you finish this thing? Excellent. Tell me what to put in for DG. Excellent. Intersected with, here's the tricky part. What is G of X? Square root of 2x plus 4. Awesome. Goes into what? Yep. So then I put it here in that, and I say less than 1. There we go. And once again, how do you get that solved? Start with squaring. You square both sides and you get 2x plus 4 is less than 1 squared, which is 1. And then I'm going to subtract 4 from both sides. 2x less than negative 3x less than or equal, no, not or equal to, just less than negative 3 halves. Awesome. Now you have to understand what intersect means. If you haven't already, finish these two and see where you think they overlap. Make a number line for each. You done already? Okay, good. I'll ask you for the answer in a second. Hold on just a second, because the video is running. Show me. Nope. When you square root a variable, you get the absolute values. When you square, you don't. Okay. So FK, tell me what you got for this number line here, it's -2 filled in bigger, and then the other one is at -3/2 circled going this way. What'd you get for a final answer when you merged those two?
Bracket -2, -3/2.
You are so right. Second here. That was a strange sound. Okay. Bracket -2 to -3 has parentheses. Raise your hand if you had that correct final domain. Okay, good. All right, let's not worry about that anymore then. Now the one that I just asked you about and said you won't need to know the formula. You will need to know how to use it. Do you remember that this tells you the slope of a curved line? So if I gave you a curve like this and said, what's its slope? You would say, well, it depends. Do you want the slope from here to here? If so, I'd have to tell you x and then how far to go over to get the next point. That's x and h. So that means bottom line, your answers usually have x and h in them. You don't have to understand all of that. That's calculus. You will have to understand that next year. Okay, for right now, what you have to understand is if I gave you 2x to the third, you'd have to be able to tell me, oh, let's put on one more thing, otherwise you'll forget. You won't practice distributing the negative here. Try this function and find the difference quotient of it. Basically, it means stick in x plus h and then follow the rest of the formula here. We've done this. We've practiced this. You may have forgotten it, but this is the review day, so fight your way through it. And oh, wait to the third. You got a good point. The third power is going to make this really hard. I'm sorry. I'm going to change it just a smidge. We'll make this to the second power because it's a lot easier to actually multiply that all out. Sorry about that. Okay. Now stick in x plus h and then finish the formula. If you don't know what's going on, pay attention in a minute. But at minimum, stick in x plus h into this function right here. Pausing. So you should have said, pay attention please. If I made two of them, why was I doing that? JS? Why did I do that? Because it was x squared. Excellent. Now I'm going to do a lot of this in my head here. That's going to be x squared plus 2xh plus h squared. Then I'm going to times it by 2. 2x squared plus 4hx or xh, wouldn't matter, plus, again, normally it'd be h squared, but I'm doubling it, 2h squared, and then plus 1. Yay for me. I have now got the first part of the formula done. Okay. Mr. A, let's see, it's A, and I can't think of your last name. Mr. A, tell me what to do for the next part of this big formula. All right. I did already multiply it all out. How about that part? There you go. Minus, what goes in there? That's the function, 2x squared plus 1. Any questions? Okay, then that's all divided by h. Would you please simplify that all the way down and see what you get? A lot of stuff cancels. That's the nature of this, is that it's meant to have things cancel. A ton of stuff cancels. Your answers will be like, 2h plus 7 or that kind of thing. Did you notice that 2x squared canceled the negative 2x squared? And that negative 1 will cancel the positive 1? So you're left with 4hx plus 2h squared all over h, if you like partial credit. Got to simplify it. Very good. Okay. It always comes down to my favorite saying. If you can factor it, you should. So I'm going to factor out an h, and I'll have 4x plus, Now, I could have factored out a 2h, but I don't need to because the only thing I can see on the bottom that could possibly cancel is that h down there. So I'm just factoring the h out. There we go. Now. Okay, so 4x plus 2h. Raise your hand if you had that one right. Okay, awesome. Next, that's a function. Does it have an inverse? Yes or no? They always have an inverse. That's correct. It has an inverse. Okay, my next question is not how do you find that inverse, but if this function's inverse is also a function, then that makes this a special function. One-to-one function. This is the part where if you're like, I didn't know that, I didn't know what that even means, I'd write it down. Okay, so if a function's inverse is also a function, that makes it a one-to-one function. All right, there's two ways to do this. I would like you to start by graphing it. I want you to see this one in a picture. Would you please graph this function? I'll pause for a second while you do that. Okay, all right, so did you graph this? Raise your hand if you had something approximating that. Okay, good. Then did you, anybody, I'm just curious, anybody smart enough to know that I was going to ask for that and already put it on the graph? Yeah, a couple people. All right. Why am I going to ask for that? Because we're talking about, this is the part of the test where we talk about inverses, right? So inverse is the reflection over that line. What line is that? All right. Then I would recommend that you practice flipping this function over that line and see what you think it kind of looks like. Pause for a second. So, did you find that it kind of looked like that? Now, I'm going to give you a tip on this. I think it's a good tip. Pay attention. It's like somebody told you 10 years ago to buy Apple stock. That would have been a really good tip. It's gone up a lot since then. And Tesla, too. All right, here's a good tip for you. That spot there, can you kind of make up a number for that? Does that look like it's maybe about 2.5? If you actually solved this, you'd figure out it was true. It's the x-intercept, right? What's the x-intercept? The same as it's where what equals what? The x-intercept is where what? Y equals 0. So I put a 0 here, and do you get how this is 2.5? Okay, so then this is 2.5. So this is 2.5 comma 0. Why do I care? Because then I can take that point, and if this is really an inverse, do you get that that's going to make, what's the most important thing about x's and y's and inverses? That they flip. The x and y flip. So that point has to be on this other function, and it will be called 0 comma 2.5. Do you get what I'm saying? And then there's another point that's important here. This guy. That's the y-intercept, and I can just look right here. The y-intercept is where x is 0, so it's -5. That must be at 0 comma -5, and that must mean what other point must be on this graph? -5 comma 0. These just reverse, right? And so then this spot right here must be at -5 comma 0. Does that make a sense to you? Once you got those 2 points, you can't go wrong. You just draw the line through the points. You can't miss it. Okay, so that's how to find an inverse with a picture. How about finding an inverse with a little 3-step process that I taught you 2 days ago? Try to remember how to find the inverse of this. The first step was just replace f of x with y. I've already done the first step, so there's only 2 steps left. Find the inverse algebraically. I'm going to pause for a second when you give that a try. Okay, we found its inverse, and it looks like this. By the way, if this one wasn't called y, instead if it was called f of x, and this new function we made were called, instead of y, g of x, we'd be able to tell them apart, right? And then how do you prove that those are inverses? With, as one student said, f of g of x. What does that have to equal? X. And then the other side, which is g of f of x, and that has to equal x. You have to move both sides if you're going to prove it. All right, I'm going to save some time. I'm just going to do the left one, f of g of x. So I'm going to start with the f function, and then I'm going to drop in the g function that it's eating, 1/2 x plus 5/2. Got a little bit small there, but now I'm going to multiply it out. That times that makes x. That times that makes, it does make 5. Minus 5. There we go. Good. And then it equals x. Yay. Raise your hand if you got it to equal x. Okay, good. Then I'd have to do the same thing on the other side, and then I've proven that they are inverses. Okay. Oh, so much to know. All right. What if I just said, here's f of x, and I'm not even going to tell you what it is, but I'm going to tell you its domain is all reals, and its range is from 2 to infinity. Then what if I said, here's, and I want to know its domain and range. First of all, what did I say by saying that? They are inverses. That little to the -1 power means that's the inverse of f of x. So I know it'd be nice if I showed you what this picture looked like of what this function was on a graph, but I'm not telling you. You should still be able to tell me its domain and range. Raise your hand if you know the secret to this one. Okay, awesome. And it really boils down to what are inverses really. The main thing is that what happens again on inverses? X and y flip, and so therefore domain and range flip, and therefore I hope you knew that the range must be the same as the domain, and therefore all reals, and the domain must be the same as the range, and therefore from 2 to infinity. Raise your hand if you knew that. Okay, good. And then your next topic, oh, so many topics. Your next topic is, what if I asked you for f of, actually let's go back to where we have two functions. Here's our f function and our g function. What do you think f of g of 17 is? F of g of 17. I need somebody to think powerfully here. Yes? Maybe. What do you think it is? Because I don't know what it actually equals. So if you actually figured out what that equals, I would know if you had it right. Yes? Okay, if we wanted to plug 17 into the g function and then figure that out and then find f of that, yes, you could. I want you to think deeper. Ooh, AC, what are you thinking? If f of g of x simplified down to equal what? Then what do you think f of g of 17 comes out to? 17, just like you said. That's it. Okay, now that would take you a lot more math to actually like multiply this all out and like put 17 in and then figure it out. All right, let's do a simpler one. What if I said f of x is equal to x minus 4, but x has to be greater than 2. And then g of x is equal to 1 over x. Then here's my question. What is f of g of 0? Who said that? What did you say? No solution. Why? How did you start? Look at g of 0. And what is g of 0? 1 over 0. That can't exist. Boom. It's dead. Okay, let's try another one. G of, let me think. G of f of 2. What? Can't work? Why? Because you were trying to figure out what? What were you trying to figure out? F of 2, I hope is what you're trying to figure out. And then you were like, oh, I can't put 2 in. Why can't you put 2 in this function? X has to be bigger than 2. Okay, awesome. Now, one you can actually do. G of f of 3. Notice the theme here is that we always start on the inside, but we're careful not to screw up our domains. Did you figure out f of 3 by sticking a 3 in here and getting -1? And 3 was okay to use, right? Because 3 is bigger than 2, right? So, okay. So when we get -1, then it's g of -1, and then there's a -1 right here, and then it's -1. Because 1 divided by -1 is -1. Raise your hand if you had that one right. Okay, awesome. Now, I have not covered everything that could be on this test. I have covered a lot of things that could be on this test. So, what I would do, if I were you, is I would flip through your notes that you've taken through this quarter. I know some people are terrible about that, but you should get better. I only know one person in my life that had never gotten anything other than a straight A in every class in high school and college. And I asked what their secret was, and it was, I take notes, and then every night I look over my notes briefly of what the teacher talked about that day. That sounds very disciplined, and it worked. A's in every class, ever. Okay, so if you take good notes, then do that. If your notes are crappy, I would then go to homework, and I would look at your homework and say, is there anything skipped? Because I could do those problems. And there's keys for that too, right? It's kind of handy. You got problems, you got keys. All right. So that's what I would do. And I'm going to pause for a second. And then I guess that's all I have for the video for today.